Now we're going to talk about circle of confusion and how it affects something called bokeh and how this works and why you're going to want an expensive lens after this. So circle of confusion controls bokeh and it controls depth of field. And I'm going to be describing this to you in two-dimensional terms. I drew this little fishy-looking thing. But if you look at it, and here it is, I want you to think of this in 3 dimensions. So this is a cone, a physical cone of light when it comes in. And so there are several things going on here. And what this represents, and I just drew this really fast. This is a lens in a camera. Okay, this is the lens in your camera. This first thing here is a point source of light. A point source of light is like this right here. This little light right here, or a light bulb. It's something, a what? A match frame?
Flame.
Flame, yes, match flame. I can't hear anything. I'm like, match frame? Match flame, match frame, yes. Yeah, getting old. Yeah, it's anything that we can see, like these lamps up here, these little beads on this chandelier here. These are point sources, these things right here. It's something that we can see as a point. And our eyes, when we focus our eyes on something like that, we resolve those points into points, and that's what we call in focus. And how that works in a camera is a point source of light, like those little things. It actually expands, and when the lens captures that, the lens is going to focus that point source of light over here, and where that cone of light converges, that is called a focal point. Okay? So where this expands, it comes back, this is called the focal point, and then it just keeps going. All right? That light just keeps going. And so what we want is this focal point to hit what is called our plane of focus, our focal plane. The focal plane is our sensor in our camera, or the film, if we had film. So what we want to do is we want to have this focused on that. That's how we achieve focus. That's how focus works. And what happens is different point sources of light at different distances will have different focus points. So that's why when you're racking your focus and you're moving that little thing, you're moving your lens back and forth. And so what happens is if you move it back, now this isn't focused because we've moved our lens, the focus is back here, or if we move it forward, it's up here. And so that's how we can choose what's in focus. Now how does that apply to depth of field and bokeh? Well, this little cone right here, if it's resolved exactly on the sensor, we get something that's clear and it's in focus. But sometimes it doesn't have to be exactly right. So if the focal plane is just off a little bit, we can still identify that thing as a point. Even though it's not as crisp as it could be, it's within the circle of confusion. In other words, it's inside of this thing that we accept as in focus. And so usually that is just a little bit before and a little bit behind this point. And that's how we get depth of field. So we have things that are at different focal lengths. They're not all going to resolve in the same place. They're going to resolve at different places. But if they're inside this little area that our brains can say, you know what, that's not exactly a dot, but it's pretty close, then we consider that in focus. It's pretty crazy. And if we have something like this, where we close the aperture down, what happens is these converge in a much more narrow way, which means our circle of confusion gets greater and our depth of field grows. And so that's why when you're shooting at something like at a 2.8, really wide aperture, or 1.2, the depth of field is really shallow because that convergence is like, boom, it's just coming in, and your circle of confusion is really, really narrow. And the opposite, when we take this aperture and we close it down, more of these little dots, even though they're not exactly in focus, will appear to our eyes as being in focus. And that's really cool. Make sense so far? Awesome. Okay, now, why does this matter? It matters because the light is bending through the lens. And that is a very important thing. Because remember, light travels in red and green and blue, right? Well, guess what? Those are not the same wavelengths. Think of them as radio stations. Radio stations, radio signals are wavelengths, right? So if you're selected at 107.5 FM. You don't hear 109 whatever. You only hear that one, right? Because the wavelengths are different shapes. The same thing is true of light. And what happens is, by the way, this is, if you really want to get crazy with, look this up on Wikipedia. And this is creative license, so I got permission. Chromatic aberration works like this. Red, green, and blue are coming into the lens at the same place, but as soon as they start bending, look at this. They show up at different points. And that's a problem because what that means is when you're bending light through the lens, you will have red and green maybe in focus, but the blue is not. So you'll have a color that's out of focus. And you can see this if you have a lens that isn't so special, when you have something in focus and you'll see like a purple fringe around things. And the reason that's happening is because two of these colors, usually red and green, are in focus, but the blue is off. And it's not falling on the focal plane correctly. And if the circle of confusion for that color is really small, you're going to have this thing called chromatic aberration. This happens with cheap lenses all the time. So lenses that are a little bit more expensive, what they do is they don't put up with this. They have things called lens elements. And the lens elements are like this. So you have this thing that's called a crown and this thing that's called a flint. And what the flint does is it corrects for the misshapen colors coming through. And so everything lines up pretty close to on target. And so that's why you have a zoom lens. A good zoom lens is usually really heavy because not only are you focusing and that's moving, but you're zooming everything in and out. And so the science of getting all of this light to fall in the same place is very, very complicated. And if you have a really nice lens, you can't just use normal glass because normal glass reflects light in weird ways. And so you get really massive chromatic aberration, and this is a chromatic aberration. And so you have to correct all of that, and so you have more and more lens elements. That's why lenses are so heavy and why they're so expensive, because it's not just glass. It's like crystal. It's really expensive stuff. It's really cool. Okay, we have 4 minutes for questions. I can't believe we made it through all of that so far. So I want to, yes, what questions do we have?
So can you talk a little bit about the relationship in distance of light from the subject versus power or number of lights and how that relates to stops?
Yes, we're going to do that, I believe, tomorrow. There's a principle called the inverse square law, and we're going to dive deep into that. But we have I think an hour on that, so I'll answer that tomorrow, or maybe this afternoon. I can't remember. It's coming. Yeah, the inverse square law stuff. We're going to take a break from all the sciencey stuff and do some more shooting for a little while, and then we're going to come back and we're going to do distance from subject and how the light falls off and why and how you can change that from a point source to, yes, it's all coming. It's coming.
And Mark, this one was from earlier, from Mile High Guy. Question, the smaller the sensor, does that mean the worse the dynamic range? So then little point and shoot should have a terrible dynamic range. Is that correct?
That is correct.
Okay.
You can try it out yourself. Get your camera phone, take a picture, and take a picture with your DSLR and just look. And the thing that's crazy is, I've got a bunch of friends that work at Intel and those places, and I used to work there. Technology for working at the nanometer, kind of like the way, way, way down, small, where chips need to be built, has increased significantly in the last 5 years or so. In fact, they're having problems building chips now because they're working at such a small level that the light coming through the devices is bending and they can't really see what's down there. So you need an atomic microscope to do some of the stuff they want to do now. But what's happening is that those sensors have improved significantly in the last probably 5 years. So if you take an iPhone 1 compared to an iPhone 5 and see what the image quality looks like, it's dramatically different. So in general, yeah, a smaller sensor is always going to have worse dynamic range than a larger sensor, but the small sensors have improved significantly. And then, yeah, there's a difference between CCD sensors and CMOS sensors, and that's maybe color theory. Anyway, yes, what's the next question?
Comment from Marty, who said that was awesome. Great tutorial on chromatic aberration.
Yay.
So very cool. And I think we have a question in our studio audience.
On the chromatic stuff here, is there an optimal setting for each lens to get less of that?
There is, actually, and this is really, again, bonus points for you. If you Okay, we didn't get to talk about this with the color checker passport. But with the color checker passport, what that does is it builds a color profile. And Adobe has done a phenomenal job of calibrating lenses to. Adobe has built all these profiles out to know exactly what the chromatic aberration is for almost every lens made. And so you wouldn't really set it in the camera. But in Lightroom, see if I can go down here and find this. There is a camera calibration setting, and you can change the profile. So these are color profiles. You can do that. But then there's also a lens correction setting, and the lens correction is up here. And if I say profile, enable profile correction, notice that it knows in Lightroom what model of lens that I've used. And so what that does is it not only helps with chromatic aberration, but it also helps with lens distortion. And so that's one of the big benefits of Lightroom is that Adobe constantly does all these calibrations to fix color and distortion. So if I undo this, what you'll see is, see the edges there, how that's changing?
So why wouldn't you just have that checked all the time?
Some people, like myself, buy lenses specifically for the deformities that they create. And yeah, it's sort of like shooting with a certain type of film because it's really highly saturated or has a nice film grain or something. And so it's sort of like a signature look. If you're shooting like with a Holga or a Lens Baby or those kinds of things, you're actually messing up perfect optics and throwing off color to achieve an artistic look. And so sometimes a lot of people will uncheck that because they don't want correct images, they want artistically correct images. So that's why. You're Mr. Adobe, is that right?
Sort of like what we talked about
Yeah.
with color temperature.
Yes.
You can have correct color or you can have pleasing color.
Right.
So same
exactly.
thing with the lenses.
There's
you want
correct, scientifically correct, and then there's artistically correct. And yeah, so these over here, we can have them all look white, which is scientifically correct. But we don't want that. We want them to look orange and warm. And so the same thing is true of chromatic aberration, those types of things. So you'll see if you're shooting and you have really nasty chromatic aberration, there's just like this blue thing around everything, and then you get sad and buy a new lens. So that's what happens there. All right, more questions?
Yeah, here's one from D-Land. How does chromatic aberration apply to prime lenses? Do cheaper prime lenses have issues with chromatic aberration like a zoom would?
Prime lenses are traditionally do a much better job with handling color because there aren't all the moving parts. And so I don't know enough to say, yeah, a cheap prime is going to be equivalent to an expensive zoom. It really depends on the prime and the zoom. So, but generally speaking, a prime lens is going to do better with focus and color than a zoom lens. In fact, years ago, most photographers would only work with primes because of that, and most cinematographers only work with primes because of that. In fact, I don't know of any cinematographers that are working with zoom lenses. But yeah, the newer zooms, as of maybe 10 years ago and newer, are leaps and bounds above what we used to be able to have happen. And it's mainly because of manufacturing processes and the ability to do really finite control and technology. It's all that sciencey stuff. All right, what's next? Thank you.
I just want to say the comments coming in about you, Mark, and the fact that people are understanding things for the first time that they've been trying to learn for years.
Yay.
A lot of those. All right, well, can we go back to a question about the color checker that we weren't able to ask before? Do you mind?
Sure.
Okay. Gecko Boy, who is from Phoenix.
Yeah, I know him.
Okay, sounds like you do. Said, is there a way to tell that you have a good photo of the color checker on location? I recently used mine, and when I got home, the color checker image looked good, but Lightroom wouldn't make a profile. Another image of it that seemed to be less ideal worked.
Yes.
So any tips on that?
Yeah, Gecko Boy and I used to play video games every day at lunch for years. So, yeah, the answer is that can I see the color checker? Yes. The problem with this, there's two things that are going to get you. When you have this, if it's not, it needs to be at a 90 degree to the camera as much as possible and level. So if this is off and skewed a little bit, even though you have it in, what will happen is to create the profile, which we weren't able to do yet. it can't see the target accurately. It's not square. By the way, Gecko Boy works at Intel. So it has to be square where you can see all 4 corners. So maybe the one that you thought was good was just skewed a little bit. The other thing that will happen with this in bright sunlight is it will have a glare. And if there's a glare on it, you're done. That won't work as well. So it needs to be flat to the camera as much as possible, 90 degrees. And then it needs to be square, not skewed at all. So my guess is either it was skewed or it had a glare. And the other thing is it needs to fill up a good chunk, 3/4 or so of the screen. The one thing that you can do though is there is a color checker utility to create profiles, and you can manually go in and tell the utility where the corners are. You can say it's here, 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 and here. And so this one was iffy on the positioning because it was just a little bit off. And also it needs to be right side up. That's the other thing. So the colors on the bottom and the people and the calibration on top, that's how it should be. So that's my guess.